Hey, welcome back. Welcome back to the bench. Good to see you again. Thanks for joining. Hope you're all well. So this is an Actron solid state 8-track player. It's called a stereo 8-track deck, but it's just a player, simple player. You stick your tape in and all it does is play tapes. And I've noticed on my channel I'm getting a lot of interest for 8-track stuff. So when I'm out and about doing my garage selling and stuff, this one I picked up for $10. You can see. There you go, $10, which I think is a good price for one of these. If you can bring it back, and you know, they're probably worth a bit more than 10, maybe 50 at the most. But this is just for playing tapes. I have picked up 3 other ones that I'm going to feature on the channel as well. And 2 of those are recording decks, so that's going to be interesting too. So watch out for that coming up. But let's get this thing going. Make a nice short little video, hopefully. It is, as you can see, it's pretty small. All in the front, it's got a select button and a slot for the cartridge. That's it. And 4 indicator lights. And yeah, that's pretty much it. Let's look at the back. The back we have power input. It says 117 volts, takes 14 volt amps. It's a model PE-301. I don't know who made this. It's got a serial number. Actron. It's probably not made by Actron. They just probably rebranded this with their name. It's probably like probably a house brand. I don't know. And then it's got 2 outputs for your left and right line outputs. Yeah, it's pretty simple. Even on the bottom 4 feet, it's got a schematic diagram. Let's have a look at this. I don't know, hopefully you can see that. It's just a simple stereo amplifier. You got your record heads here, or sorry, your playback head here, right channel, left channel. A 2 transistor amplifier to boost the signal up to line level, and here's your line outputs right here, right and left. A little simple power supply, full wave rectification. It's got like a little 2 diodes, a cap, 2 caps, a resistor in between, so it's got like a pi filter network. And then it goes to the motor, switching, solenoid for doing your track jumps, and a little diode there for blocking the back EMF on the solenoid. Program lamps are all wired in. There's a switch here. It's pretty basic. Nothing to go wrong really. Usually the only thing that goes wrong with these is mechanical. Made in Japan, eh? Is it made in Japan? Printed in Japan. But that's it. What kind of transistors are we using here? It doesn't say. It is they're PNP. So they're probably germanium. That's my guess. Yeah, it's pretty old. This is probably in the era of PNP transistors. So let's have a look at what it does. Okay, so let's plug it in so you can get a read on what it does or doesn't do. So let's plug this in. I didn't notice. It doesn't have any power switch on. Yeah, that's the transformer's live all the time when you plug it in. So let's plug this in. And we're consuming 0.85 watts, which is typical for a transformer that's sitting idle, not doing anything. So that's working. So let's plug a cassette in, or a cartridge. You can hear motors. And I can hear the tape moving. And we're only consuming 3.9 watts. Track 1, bulb's lit up. Track 2, 3, 4, back to 1. Seems to be working. Let's get an amplifier. Okay, so I got the good old realistic SA155 here to help us out. And we are going to try this again. This is Harlequin, victim of a song. Sweet things in life. What's your name? Survive, victim of a song. You are the light. Who knows what a love can do? What a love can do. Shame, shame, beginning. Shame, shame, conclusions. See, here's a problem with 8-tracks. They put half a song on track 3 and half the song on track 4. So when you're listening halfway through the song, it does the big chunk, and Yeah, it kind of takes away from the mood, but it is working. Pretty muffled. Oh, it's making odd noises. Everything's good this way. So, you can hear that? I think that's within the tape. The tape is making weird noises. Okay. I don't know if that's the tape or the machine itself. It doesn't look like we got any repair here. Just really muffled sounding. Probably needs a good head clean, demagnetize. Doesn't look like it's got much wear. Let's take it apart. Let's go through and lube everything, check everything out, make sure the caps are good, and we'll just give it a general service, and then we'll listen to it again. Okay, so we got back cover. Typically the way these come apart is you take these 4 screws out, and then the chassis slides out the front. Or maybe the back, I'm not sure. No, it goes out the front. And then they have this back plate here just to cover everything. Have to remove it because we won't be able to fit the power cord through this hole. So let's just remove this back plate. It's all wood screws. And looks like we have a little bit of plywood action for the case and a little bit of all these screws loose. Yeah, this is the problem with this particle board department store stereo stuff here. So let's try this. One last screw here. Special acceptance. I wonder if they had to make some kind of special accommodations for this thing. It's got it over top of another sticker. Serial number yet. That's impressive. Okay. And then we're starting to see what's going on inside, so let's take these 4 screws out. Okay. Oh, it does go out the back. Okay. There we go. Yeah, it's just a plywood box. Everything's glued in place. It's nice condition. Put this aside. Let's have a good look at this. Okay, so here we are. This is our belt. And the belt looks not too bad. It just needs a good cleaning. It's holding up pretty good. It's got some slip to it, but I think the cleaning will help with that. It's got a little bit of a lump there, as you see, it goes through. Might give it a little bit of a wow. Power supply, power cord comes straight in, goes to the primary, little tiny power transformer with the center tap. Here's our power supply board. And on the power supply board, they also have connections for the outputs. No, this is for the heads, I think. No, this is the outputs here. Little tiny power supply. So it comprises of a dual diode and a 220 microfarad and a 470, and a little resistor in between the two of them. This circuit here, I don't know why there's a trim pot here. Is it like a balance control? Let me have a look. So what they're doing is they have one output here. This transistor goes through this capacitor. DC blocking capacitor goes through resistor to the output. Other channel, same thing. Blocking capacitor, resistor, output. And then they have this trim pot here. It's a 250K trim pot connected to ground. The center tap's connected to ground, and it's like a balance control here. I don't know why they did that. But that shows up here on this little board, little trim pot, and then our outputs, which could use some tightening. Okay. Motor. Here's our main power switch. Here's the switch for the track selection. As a little piece of foil on the tape comes by, it makes contact on these two electrodes, and it does activates the solenoid to switch to the next track. We got 4 indicator lights, one for each channel, or each. Here's the bottom of the chassis. It's all point-to-point wiring. It's like quite a mess, but it works. The terminal strip here with the diode, and this is for the solenoid. The mechanism that changes tracks. And here's our little amplifier. It's got a Russian capacitor on there. Kirchia. Let me zoom in on these capacitors. You see that? I don't know if that's Russian or if that's... Oh, they're Japanese. Never heard of that brand before. So we got a little amplifier here with some, what are these? 2SB 303, 2SB 303, 2S, what is this one? 2SB 186. Signal input comes in on these two coax cables, which is crudely connected to the board. Input blocking capacitors, 2 transistors, another 2 transistors, and 2 output capacitors. I think I'm going to end up just replacing all these caps. Let's do some testing first and see how bad they are. So I'm trying to remove this amplifier board just to get to the underside, and this screw here is completely stripped. It almost like they took a drill to it to completely obliterate the Phillips socket, but you know, it's not going to turn at all. I'm going to have to get creative here, I think. But it's still locked in with the green thread locker, so you can get it out this way. It's no problem. It's going to take a little bit of time. Okay, finally got it out. Have a look at this fine construction. Quality control here. Look at the resistor on the edge of the board there, just barely hanging on. And here's another one that's pretty close. Right here. Right here. Another one. So they, oh. This one's pretty close too, so they saved a bit on PCB board material. Alright. Surprisingly enough, the board is marked with plus and minus, or plus for the, yeah, plus and minus for each cap. So let's try this one out. This is a 10 volt 33, or 3.3, 33. That one's okay. A lot of these will be okay. This one here is 220 at 16 volts, and that measures okay. It's right on the limit. Here's another 33. Input blocking. Ooh, that one's a lot higher. and its buddy. That's the main filter cap. It's a 470 at 16 volts, and it's measuring out at about 1/4 of an ohm. It should be a little less than that. There's one right here. 3.3, we measured that one. $10. That's no good. $8.7. That's no good. $6.4. It's probably borderline. It's the input capacitor here. 16. That's no good. Yeah, so we're going to do a recap on this. 18 on the other channel. Yeah, these caps are really tired. It's no wonder they're from the era of germanium transistors, and that dates it back, you know, early 70s, I think, or maybe even earlier. I don't know if there's any date codes on here. Usually there's a date code on the motor. 7302, I don't know what that means. That could be a part number too. Oh, what's this? 48210, I don't know what that is. Alright, get some new caps in this thing first. Alright, so half hour later I got the caps in, all 14 of them, and looks pretty good now. Something for the new players that they should know. These boards, these old PCB boards from back in the days when they had germanium transistors and stuff, these are really, you got to be real careful with these, because if you put too much heat on these pads, they right away lift off the board. The adhesives they used was pretty poor. So, trap for the new players, you got to be careful. First thing you should do is just turn your iron down. You don't need to have it cranked up that high. And just be careful. Don't use too much heat on that joint. Don't leave the iron on too long. And clean it up after you're done with alcohol, and have a good inspection too. So these caps, I've never seen these brands before. Kureha, and they're made in Japan. It's weird. And then we got, here's another trap for new players. These old caps. And look at this. This one's marked for negative. This one's marked for positive. So you have to keep on your toes when you're pulling these out. If you see a line there, it doesn't mean negative automatically. It's could be positive. This is Druson. Druson. Never heard of that brand either. And then we have a third brand here, Sanko, Sankyo, Sanko. There's another one. They're all high ESR. They're all way out of whack for tolerance, so they all had to go. So this is all done. I can put this back in. I can reinstall this, and we can focus our attention on the mechanicals now. Okay, so I think what I'm going to do next here is go after the motor and do lubrication, clean this belt. You can see the outside looks perfect. The inside is a little dirty, a little worn. It's not a big deal. It's a good belt. It does have a little kink in it from sitting for so long. See that one spot there in the middle? But not much you can do about that. Okay. That bearing feels okay. It spins for quite a while. We'll take it apart and clean it anyways. Okay, let's take this motor out. See what we can do with it. If it's easy to take apart, we'll take the motor apart and clean and lubricate it. If it's not, oh, look at this. Loose connection here. You can see that. Let me zoom in. See this bad connection here on this terminal strip. I don't know what that's for. That's the way it was when I found it. Fix that up as well. Okay, so we got two wires, orange and black. Let's pull the orange wire. Where's my tweezers? Okay. Gotta remember where that goes. And this black wire is part of the loose. Get that out of the way. Surprising this thing ran. Okay, black wire. Now I got 3 screws. Ooh, they're tight. They don't want to turn. I don't want to strip them. There we go. Looks like they were using thread locker on them. Wow, these screws are tight. Okay. Let's cover off. Take the whole motor out actually. There we go. Put this aside. Okay, so we have a couple set screws. It's like they glued this thing on. I know it. It's not a very big shaft. Oh my God. Shouldn't be stuck on like that. Oh. Be careful when you're putting torque on a shaft like this, because if you bend it, you bend the shaft and it's going to wobble. That does not want to move. What I'm going to do, take those screws right out. I'm just going to heat this up. I just don't want to melt the rubber behind it. Just want to get this good and hot. There she goes. Let this cool off somewhere. All right, back to business. So we got a motor housing here, and it has wraps of the, it's called mu metal, And it's kind of a iron-based metal that is for shielding magnetism. That's what this is all about. And here's our motor. Looks like it's still shrink wrapped. Okay. That can come off. Let's open this motor up and clean it out. Give it a clean, we'll give it a lube, put it back together. Let's get rid of the shrink wrap. It's kind of interesting. I've never seen it shrink wrapped like that before. Now you never pull the back end off because you rip the brushes off the commutator. What you got to do is push on the shaft and allow the whole thing to come out on its own, just like that. And is there something I can get a grip? Now you're going to be fighting the magnetism here. Let's get something under there. No, that's not going to work. Let's take this end off. Just got to pull the brushes back. Let me see here. You see the brushes here? One brush, two brushes. There we go. Perfect. Now we can pull this out. This bearing's dry. This bearing here is dry. Let's put some lube on it. I'm going to use synthetic grease instead of oil. I have a feeling it's going to stay in place better. Got a big C-clip in here if you wanted to remove it. Remove the magnet. I don't know why you would want to do that. Okay, let's clean the rest of this. Clean the slip ring. Yeah, it's quite dirty. Let's clean the brushes. Quite dirty as well. Okay, I think we're good. Now they got noise suppression caps in here. Let's try and measure some of these. It's got resistors across it too, so that's no good. It says it's 11.48 microfarads. 11. Yeah, it's got resistors across it, that's why. I'm really not interested in replacing these caps. They're just noise suppression. And these caps as well, these are noise suppression. It's a fairly well-built motor. What's going on under here? You got speed adjustments and contacts. That's how you adjust your speed. So, as this spins, there is a weight here. Let me see if I can zoom in and show you. As this spins, there's a spring. This is anchored to the body of this rotor. And then there's this spring, and then there's a weight, and then there's a contact here with an adjustment. Right? So as this spins, the centrifugal force pushes this weight out and opens this connection. See? And that's after it hits the predetermined speed. If it doesn't open soon enough, the motor will go too fast, and if it opens too soon, the motor won't go fast enough. And you adjust it with this little screw here. And you can do that through the side of the motor. There's a window for making that adjustment. This is probably hasn't been touched since the factory, so I don't know how we're going to test for speed. We don't have any test tapes, but we're just going to leave it alone for now. I just wanted to explain this to you so that you understand. If you ever do need to go in and adjust the speed, this is how you do it. It's kind of a governor. And then these contacts can go bad too, right? I'm pretty sure they're silver. So anyways, we're good to put back together. Let's put this back together now. First thing we need to do is lubricate this end bearing. I'll put some here inside. We'll put some on the end of the shaft. Don't get any lubricant on the copper rings or the pickup or the brushes. So how do we do this? We have to this is where you need 3 hands, because you got to spread the brushes. I know you can't see, but there we go. Okay. Now I screwed up because before you take it apart, you're supposed to mark the orientation of the end cap. I didn't do that. So it might be 180 degrees out. And one way to tell is just put power to it. Let's see here. Get a 12-volt power supply. Put some power to it. Black is negative, obviously. Positive. Okay, let's try doing this 180 degrees out. Let's try it this way. Okay, that doesn't feel right. You feel the motor's it's jerking. It doesn't feel smooth, and I can feel it's not right. So I'm going to put it back. It's kind of hard. You can't really tell on the camera, but it didn't feel good at all. It didn't spin properly. So let's go put this back the way it was, 180 degrees. Put the screws in. Let's seal this thing up. Let's try it one more time. It's better. Smoother. It's drawing about 45 milliamps at 12 volts. Okay, what I'm going to do is let this run for about 10-15 minutes just to allow it to distribute the lubrication. This is why I let it run for a while when I put it back together, because when it first started it was drawing about 45 milliamps or so, and after a while it drops. Current consumption will drop. It's down around 38 milliamps now, and it just allows the bearings and the brushes to seat themselves, and runs a little smoother and quieter as it goes. Okay, I think we're done with this. I'm going to just kill the power and we can just reassemble this. Let's put this back together. So this part goes on this end, the rubber insulator, and this part goes on this end. Okay, it goes on that end. Let's install this in the case. It's good. The back cover. Oops. Okay, so that holds everything together. Got this a little bit out of, there we go. Okay, good. Let's put this pulley back on. Ooh, it's going to be tight now. Tell me I got to heat you up again. Might have to get a drill bit and clean this hole out. It is full of that sticky stuff that... Okay, what do we got here? 975. $975. I have a 9.8 here. Yeah, it's definitely something sticky in there. It's all that blue thread locker. There we go. Okay, I think we're good. Good. Try one more time on the power. Nice and smooth. It's not vibrating really hard. Nothing's out of balance. I'm drawing about 42 milliamps now. A lot of torque. So, let me put this back in. Let's go after this belt. I'm just going to use isopropyl and a Q-tip here, a big jumbo Q-tip. Get lots on there. Just going to drag it through several times. Oh yeah, it's picking up some dirt. Getting better. Not bad. Cleaning up nice. Let's give it one more. Good. Let's clean the outside while we're at it. Not that that's going to make any difference. Okay. Looks a lot better. So I want to clean and lubricate these bearings. There's a bearing here. There's a bearing down there. Or actually on this side. Looks like this is all held in with this one collar here with these two lock set screws here, locking set screws. And that holds on the latching mechanism. You can see it there, it's got 4 little latches on it. And this is what catches when it's spinning, and it catches, does the channel change. You can see it go into action here. You can work it through. This is ratcheting here, so every time the solenoid kicks in, spins and ratchets, spins, ratchets, and it's made so that it can only go once. Everything's working. So I'll lubricate it. So let's take these 2 set screws out, pull that shaft out with the flywheel, clean everything, clean the bearings, reassemble, and then we'll put this back together. Okay, let's do this. All right, so we want to remove this little collar there. We got a plastic bearing here, and the end of the shaft is rounded, so it rides on that because, you know, of course, gravity. This is the great way up. So We have about 1mm of play there. You can see that, maybe even less than 1mm. Could measure it, but who cares? We'll just have to remember to put it about the same when we put it back together. So let's get our little Allen keys. And I think this one here is, let's see if I can measure it. Let's measure it. Let's go metric. I think it's like a 2 point something. No, it's a 2mm. Okay. 2mm. So let's go in here and loosen this. Maybe it's not a 2mm. There, it fell in. Okay, loosen that one off. Let me see if I can get another. I could take this plate off, but then I would lose a lot of the alignment of the head. So let's just loosen that off. Let's take this one. Let's do the next one. There we go. That's loose. So this comes out. And this comes out. All right, let's have a good look at this. I've seen a fair bit of use. Bearings are dry. So we'll clean and lube this and reassemble. Now you can get a good look at the head. The flywheel's out of the way. We got a dirty head. Let's clean it while we're here. We got access. Let's clean it. Yeah, it's got a big blob of black stuff in the middle. Clean the guides. Clean the track selector switch. It's loose by design, I think. Really no wear on there. I don't feel any wear. It was just a little bit dirty. Okay, let's demagnetize it. Okay, so demagnetize it. I don't know if it's going to make any difference to this shaft, but I'm trying to get the head should be done. Let's try cleaning this first with contact cleaner, and then we'll give it a shot of alcohol. This is doing a pretty good job of removing all the crud. Just keep going. It's doing a good job. Look at this. Let's give it another shot. Yeah, it's mostly clean now. Okay. That's good. Let's lubricate around the base. Where is my lube? Let's give it a shot of this synthetic grease. Personally, I prefer putting a synthetic grease on rather than an oil because the grease stays where you put it and the oil kind of just flows anywhere it wants. So that's my reasoning. I don't know if probably a lot of people disagree with me on that one. Okay, so we need to put lube. Oh, we need to clean these bearings. Put my cleaner away too quick. Okay, let's clean these bearings. Yeah, it's doing a good job, this stuff. Okay, now we can reassemble. Okay, lubricate this bottom bearing. Now the reason I do this, I put lube here and lube here, is because when I put it back in, if I lube this top bearing, it would smear all across this surface and it would contaminate the tape path. So I slip it in dry. That doesn't sound good, I shouldn't say that. I put it in dry. No, it still doesn't sound good. Oh, look at that. Spin it and it'll go for about half an hour. Now I already cleaned the outside surface. Probably could use another one. There's still stuff. Yeah, I'll clean it one more time. Let's get this back together. What I need to do is get this back on. I should have done that. Let me lubricate the end of this shaft too. Put a little dab on the end where it rides. Okay. Let's tighten this one. This is not fun. There we go. I got a lot less play in it now, which is okay. Tighten that. Just as long as the mechanism works, latches and it changes tracks, we're okay. Tighten this one down. It's good. Any oil on this is going to get... What do I use? I want to use, let's try contact cleaner on this first. Let's see if this pulls anything off. A little bit of something coming off there. Okay, let's use alcohol. Yeah, it's not going to get any cleaner than what it is. Let's do this. That's pretty much clean too. We're good. Let's put our belt back. Okay. I happen to think we're ready for a test. This Elton John tape makes an awful squealing noise. This one's actually working. Sounds pretty good. It just makes an awful squealing noise. We know it's not our motor, it's not our flywheel. Everything's been relubed. I bought a bunch of tapes here in the summer. Look at this one. That's probably a collector's item, but then look at the tape. It needs to be spliced. Yeah, look at this. Came apart at the splice, and the foam is all just disintegrated. You know, that needs to be fixed up before you can play it. You can't even play that. Put that one aside. Let's go with the Harlequin one again. This one made an awful noise inside, but it has the foam intact. No, it doesn't, not really. Sounds like it's struggling. There's something loading the motor down. I don't think it's... It runs fine without a tape. Okay, I'm going to call it done. Okay, that's it. It's back together, looking good, sounding good. Actually, it sounds better than I expected. I didn't really adjust the head at all. I tried tweaking it, but it didn't make any hill of beans difference. Here we go again, Mr. Pester. If anybody you know who Mr. Pester is. This was recorded live at Prince George, BC. So let's finish off with this. Yeah, thanks for watching. Hope to see you on the next one, and take care.
Hold it, buddy. Turn and go. We got some crazy guy to Wagerville. 3 guys that run the church, you know, they're elders to the church, the son of a gun. So they call good meeting, say bring bottle Horyuko, we're going to go to the beer parlor, drink Horyuko, and take beer chaser. So they sit in that damn beer parlor. Pretty soon John says, Peter, you call this damn meeting, church meeting, what you call it for? He says, well, guy, so I've been thinking we need something for the church. He says, what we needed? He says, we need chandelier. Says, chandelier? He says, if we order one of those goddamn things, who could spell that goddamn word, chandelier? He says, number two, where are we going to find the son of a bitch who could play it? Says, and number three, what we need in this church more than anything is more lights, not the chandelier. Some crazy bugger, you know?